Hello guys, today we're going to continue yesterday's lesson of quadratics. Now, the first thing we're going to do is focus on example 3. Example 3 tells us, determining whether the function has a maximum or minimum value and then find that maximum or minimum value. And the function that I'm given is the following: f of x equals negative 3x squared plus 12x plus 11. Now, the first question I'm asked is determine whether the function has a maximum or minimum value. It's pretty straightforward. We talked about this yesterday. The leading term is negative. It opens downward, so it actually has a maximum value. Question 1 is answered. Now we have to find that maximum or minimum value. All we have to do, again, is find the vertex. As we did yesterday, I'm going to label my A, my B, and my C. I have that my A is negative 3, my B is 12, and my C is 11. Step 1, find the axis of symmetry. Axis of symmetry is negative B over 2A. Again, I'm going to open up my parentheses just to make things easier. I put my B value in here, I put my A value in here, and then I multiply. I'm left with negative 12 over negative 6. Simplify, I end up with 2. So now I know that my input has to be 2 in order to find the vertex. I go back to my original equation, and now I substitute the x's for the value 2. But again, always put the parentheses and proper PEMDAS. I'm going to put a 2 in here and a 2 in here. 2 squared is 4 times negative 3, negative 12, plus 24, plus 11. I add everything. This is 35 minus 12, 23. So when I input 2 into my axis of symmetry, I end up with a maximum value of y equals 23 when my x value is 2. And that's pretty much how you find the maximums or minimums. You determine if you're looking at a maximum or minimum based on the sign of the leading term. Find the axis of symmetry. It's going to give you a number. Plug that number into the original equation. It's going to give you an output. That output will be the maximum or minimum at the x value that you used as an input. That's pretty much it. Now we're going to move on to factoring. Yay, factoring. We know we all love factoring. Now, note, I will give a factoring workshop again this year, so just stay tuned for that. But right now, I'm given a standard form equation, and I'm asked to factor. Note, some students try to just plug in random values and brute force their solution. Don't do that. It's going to take too long. You're going to waste so much time. Just skip it. It's going to be better. But when you're given a standard form equation, when you try to factor it, you have to find two numbers that when you multiply those two numbers, you get this number. And when you add those two numbers, you get this number. Now, the way I do it, I think it's very simple. We try to find all the positive factors of this number. And we always begin with 1. 1 times 12. Always begin with 1. Students forget the 1 sometimes. 1 times 12. And it doesn't matter whether this number is positive or negative. You're always going to give the positive factors. Then I go 2 times 6. 3 times 4. 4 times 3. Once it starts repeating, you stop. There are no other factors. You go down this list. Now you're going to look at these numbers. And then you're going to see, after you have the factors, how can you end up with this negative 8? Looking at these numbers, and know that you can change the signs of all or any of these numbers. You can change the sign of one number. You can change the sign of all the numbers. How do you end up with this number now? So with the factors of this number, which ones can I add to end up with negative 8? I look here, I know that if this was a negative 2 and this was a negative 6, and I were to combine those two numbers, I would end up with -8. There is no other solution for this. So I know that the solutions, or that the factors, and again, some students get confused, the factors are gonna be always x, the first number, x, the second number. Those are the factors. And again, let's confirm that these are the factors. You don't have to confirm normally, but I'm gonna show you. If you multiply x minus 2 and x minus 6, -2 and -6, when you multiply, you get 12. Here I multiply, I get -6x, I get -2x, and I get x squared. When I add them, I'm left with the original function. So you know you're working properly. Again, you don't always have to confirm. I'm just showing you that this process is correct. So again, to repeat, find the factors of 12 or the factors of this number, that when you multiply, you get that number. And then you just look and try to, when you add those numbers, end up with the middle one. In this case, it was -2 and -6. Now, please note that these numbers are not the solutions. The solutions are the numbers you plug into x that gives you a value 0. And it's always gonna be the sign, the number with the sign opposite to this number. If this number is -2, the first solution will be 2. If this number is -6, the first solution will be 6. If something were flipped and this would be a positive number, then it would be -6. But in this case, since it's -6, the answer would be the opposite number, or the solution. So the solutions to this equation are 2 and 6. It's not an ordered pair, 2 and 6. No, it's just the number 2 is a solution and the number 6 is a solution. And again, let's confirm. I like confirming. Let's try the 2 first. 2 squared is 4, minus 2 times 8 is 16, plus 12. 16 minus 16 is 0. That is one solution. 0 equals 0. Let's try the second number. 6. 6 squared is 36, minus 8 times 6 is 48, plus 12. 12 plus 36 is 48, minus 48 is 0. 0 equals 0. That is another solution. So again, this is just a refresher of factoring. We will have a factoring workshop later on. Just remember a standard form, how you factor it. 2 numbers that multiplied give you this, and when you add those exact same 2 numbers, you get the middle one. Now let's continue with the next subject. Again, something you saw last year, and we're gonna be reviewing later on. Solving by completing the square. So now I'm told, or I'm given, this equation. And note, if I were to try to do the previous example of factoring, there is no way to end up with this number, so you can't factor this. You're missing something. So what you do here is you're completing the square. You're gonna add what's missing in order for you to be able to solve this particular problem. Whenever you complete a square, you're gonna do the exact same process. Step 1, get rid of everything that does not have a variable and send it to the other side. So here I'm gonna do -1, and this becomes x squared minus 4x equals -1. Now again, you're gonna label your A and your B, just like a normal standard form equation. My A is 1 and my B is -4. Again, you always attach the sign. But for completing the square, you're gonna use the following formula. B over 2 squared. That's it. B over 2 squared. I'm gonna plug in my B in here, parentheses within a parentheses, that's fine. I'm gonna plug in -4 in here. And again, that's a habit I do. You do not have to plug a parentheses in a parentheses. I just like to do that. -4 divided by 2 is gonna give you -2. And when you square that -2, it becomes 4. Now that 4 is the number you have to add to both sides in order for you to be able to complete the square. Now let's see what's gonna happen. I'm gonna add 4 to this side. So I added 4. But since this is an equality, think of it like a balance or a scale. If I add 4 on one side, I have to add 4 on the other side in order for the equality to be maintained. And this is what we did here. I took 1 away from one side. I'm gonna take 1 away from the other side in order for it to be balanced. Here, I completed the square. I added 4 to this side, and I also have to add 4 to this side. Note, this is one of the most common mistakes students do. They add it here, and they forget to add it here. Don't be that person. Add it to both sides. Let's be equal here. So now that you have this particular statement, once you complete the square, there are 2 ways you can work this. Normal factoring, like I just showed you before, 2 numbers that multiplied give you this or added give you this, which would be x minus 2 and x minus 2. When you multiply these 2, you get 4. When you add these 2, you get negative 4. However, there is a quicker and better way. When you complete the square, it's going to give you like a perfect square or a repeat 0. It's called a repeat 0. You'll see that later this year. All you have to do is write a parentheses. What is the square root of x squared? X. What is the square root of 4? 2. And then you just square that number. Note that since this is minus, this has to be minus. And that's pretty much it. Now, what do I do here? Continue working. -1 plus 4 is 3. I'm left with this particular equation. In order to isolate my x, you're going to do a square root of both sides. The square root cancels the second power, and you're left with the following expression. You're left with x minus 2 equals the square root of 3. Again, you want to isolate your x. I'm going to add 2 on one side, add 2 on the other side, and you're left with x equals 2. I'm just going to reorder it, plus minus square root of 3. And you're done. You just completed the square. So again, the whole process of using this formula to complete the square allows you to add a number that will let you express whatever you're looking at in like this manner, so you're able to use a square root to continue isolating. Again, we will see more problems later on, and you saw this last year. It's pretty much a refresher of completing the square. And to finish off today's class, we're going to be looking at the quadratic formula. Students freak out. There's no need. It's pretty simple. So you have that the quadratic formula is minus b plus minus square root of b squared minus 4ac over 2a. Now here is where I suggest you always use the parentheses method. Again, let's say I'm given the following equation. X squared minus 4x plus 15 equals 0. I know that my a is 1. I know that my b is -4. I know that my c is 15. Students always mess up with the signs, because some students say, oh, well, b is negative, I'm just going to put a -4 up front. That's incorrect. You'll see what happens again when we put the parentheses. Put your parentheses. Now we populate the parentheses with their values. B goes here, -4. B goes here again, -4. A goes here, and C goes here. A goes here. Now I'm going to multiply everything. -4 times negative becomes +4 plus minus square root of 16. And I multiply all this, minus 60 over 2. I'm going to continue working on this side, or actually I can just go ahead and erase this here. I'm going to end up with 4 plus minus square root of negative 44 over 2. Now, note one thing. There's a couple of things that are happening here. Remember, when we look at the quadratic formula, once inside the parentheses is called the discriminant. It's going to tell us whether we're looking at one imaginary, one real, or two real solutions. If the discriminant is a negative number, as is this case, we're going to have an imaginary solution or two imaginary solutions. If this number is 0, we're only going to have one real solution. If this number is any positive number, we're going to have two real solutions. You'll see that later on as well. Let's continue working. Now, I'm going to simplify this root. This root, remember, when we're looking at a negative root, I'm just going to work on the root on this side so you can see the answers. I have negative 44. Negative 44 is the exact same thing as 44 times square root of negative 1. Square root of 44 is the same thing as square root of 4 times 11 times square root of negative 1. Now let's start simplifying. Square root of 4, square root of 11, square root of negative 1. Square root of 4 is plus minus 2. Square root of 11 stays as is, and this becomes I. So I have, in the end, that here I'm going to put 4 plus minus 2 square root of 11 I. Now we can still simplify this further. I can divide my entire numerator by 2. This becomes 2, this becomes 1. So the answer would be 2 plus minus square root of 11i. And pretty much those are the two answers. 2 plus square root of 11i, 2 minus square root of 11i. And that's it for solving using the quadratic formula. We will be using the quadratic formula more this year, so we'll see it later on. And again, this is pretty much a refresher of what we did last year. Take care. I'll see you tomorrow.